In the last video that we watched, we talked about how isotopes have a different mass than each other, and the differences in their masses can be attributed to the difference in the number of neutrons. When you take all of the different isotopes of an element and you weight their averages together, you come up with the atomic mass. So an atomic mass is a weighted average. If you think about an atomic mass kind of like being your grade in a class, you kind of get a better idea about how it's calculated. So think about the most important parts of a class grade. Your homework in a class does not count for the same number of points or percentage of your grade as, say, your tests do. Okay, so when you're calculating atomic mass, you're coming up with that average. That average is what's visible in the other boxes on the periodic table. So when you say look at carbon, carbon has several numbers in the periodic table. One number that it has, that's 6 up in the corner. That's the atomic number, the number of protons, and consequently the number of electrons, because atoms aren't electrically neutral. But down below that number, there's another value. This right here, 12.011, is the average atomic mass of a carbon atom. That's taking into account the different isotopes that make it up. To calculate the average atomic mass, you must add together the weight contributions or mass contributions of each of the isotopes in a sample. In this problem here, we have two different isotopes. We have rubidium-85 and rubidium-87. The 85 and the 87 are the masses of those particular isotopes. So we're going to write that down. We have 85 AMUs and 87 AMUs. To solve this problem, what we're going to have to do is multiply each of these by their percent abundance. The percent abundance is the amount of each of these things found in nature. So if I were to grab a handful of rubidium, 72.2% of all the atoms that I grabbed would have a mass of 85 grams. We're going to multiply that 85 AMU by 0.722, the percent written as a decimal. We're going to multiply the 87 AMU for the secondary isotope by 0.278. When we multiply the top, we get a value of 61.37. When we multiply the bottom, we get a value of 24.186. The final step in the process of taking the weighted average is to add these two mass contributions together. In this case here, our rubidium's average atomic mass is 85.556 AMU. And this is how you solve an average atomic mass problem.